Very good morning to all. I am S.IMMANUEL, Assistant Professor. Today we are going to discuss about the spectroscopy, the basic principles and introduction. The subject is Allied Chemistry for Physics, subject code 20ACH301. What is spectroscopy? Spectroscopy is the branch of science. The definition of spectroscopy is the interaction of electromagnetic radiation with matter. Third one, what purpose we are studying the spectroscopy? Why we are studying spectroscopy? We are studying the spectroscopy. We are observe the atomic and molecular structure and analysis of most of the sample. So this is the spectroscopy. So we are take any source, light or lamp that produce electronic radiation and magnetic radiation. Particularly that electronic radiation, magnetic radiation interact with any object that is called as spectroscopy. So in this technique we are known unknown compound. This is the most applications of spectroscopy. Next, what are the terms used in spectroscopy? First one, electromagnetic radiation, wavelength, frequency. These three are used in spectroscopy terms. First, we are going to explain what is electromagnetic radiation. Electromagnetic radiation, also called as electromagnetic nature or radiant energy. Shall we go to the what is electromagnetic radiation definition? First point, the interaction between the electrical field and the magnetic field. Second one, electronic radiation and magnetic radiation is divided into number of regions according to their wavelength. It can be represented as a lambda. So, the electronic and magnetic radiation only produce the number of spectroscopic studies. So, some regions will be according their wavelength. So, in electromagnetic radiation travel in vacuum wavelength. So, that wavelength only produce the different types of spectroscopy. For example, gamma, X-ray, UV, visible spectroscopy, IR spectroscopy, microwave spectroscopy, radio wave spectroscopy. These spectroscopies are classified into the electromagnetic radiation. At the same time, the wavelength regions only separated and classified into the different types of spectroscopy. Next one, types of energy transition. What are the energy transitions are occurred in the spectroscopy studies? The first one, electronic energy levels. Second one, vibrational energy levels. Third one, rotational energy levels. There are three energy levels will be present in the energy transition technique. In electronic energy level, the region of spectrum, an example is ultraviolet spectroscopy. The energy transition in UV, electronic transition. In this technique, at room temperature, lowest energy level 0. After they observe the UV radiation or electromagnetic radiation, the UV visible light lone pair of electron promote higher energy state E1, E2 and etc. So, any electronic and magnetic radiation interact with any object or molecule or atom, the atom or molecule is move on ground state to excited state. This is the electronic energy levels. Especially in electronic energy level, the UV visible light spectroscopy, the molecule observe the UV visible light. The lone pair of electron promote higher energy level E1, E2, E3. This is the energy levels of electronic transition, especially in UV visible spectroscopy. Next one, vibrational energy levels. The region of spectrum is infrared. In vibrational energy level, the example of spectroscopy is IR, infrared spectroscopy. The energy transition vibrational. So you pass the electronic and magnetic radiation in particular molecule. The molecule not observe the electronic radiation. The molecule observe the electronic and magnetic radiation. The molecule will be promote vibration. This vibration only occur ground state to excited state. So in first point, the less energy level than electronic energy level. Energy levels are small, 0.012 10 kilocalories per mole. Rotation energy levels. The region of spectrum is microwave. The example of rotational energy level are rotational spectra. Microwave is the example for rotational energy level spectroscopy. The energy transition rotational. So you pass the source of the electronic and magnetic radiation. The molecule will be rotate. That is called as rotational energy level. Not observe, not vibrate. In this rotational energy level, you can pass through the electronic and magnetic radiation in atom or molecule. The particular molecule or atom will be rotate. This is called as rotational energy level. The first one, energy levels are quantized. Second one, energy levels are smaller than vibrational energy levels. This is the examples for rotational energy levels. Next one, wavelength. What is wavelength? It is the distance between two adjacent peaks. It is denoted by the symbol of lambda. Wavelength is expressed the length in nanometer. In nanometer, 10 to the power minus 9 meter. Picometer are non-SI units of angstrom. This is the units of wavelength. The definition of wavelength is the distance between two peaks, adjacent peaks. This is called as wavelength. The symbol of wavelength is denoted by lambda. Just look at this image. This is the wavelength definition. The distance between two adjacent peaks. This is called as wavelength. The wavelength is denoted by the symbol of lambda. Next, frequency. The frequency, the symbol is denoted by mu. The number of waves crossing a point in unit time. In unit time or per second, how many waves are crossing? That is called as frequency. So the number of waves crossing in a point, that is called as frequency. The wavelength is the distance between two adjacent peaks. So the distance is also called as wavelength. The number of waves produced in per second, that is called as frequency. The frequency is expressed in second inverse or hertz. So this diagram explains in per second how many waves are crossing. This is called as frequency. Thank you.